Hello, Miss S. This is Aaron Rohde, and I'm here with Unit 1, Lesson 1. Rate of change is the rate of which a group of data is either increasing or decreasing. Rate of change is usually found by using average rate of change. Average rate of change is represented by the equation change in y over change in x. So, you find the y value after the interval that you're measuring, and subtract the interval's value before the interval you're measuring, and divide that by the difference of the two intervals of which you got those y values. You see above, a baker is heating his oven to 450 degrees. This problem wants us to estimate the rate of heating predicted by each graph in a table 5 minutes after the oven is turned on. Be sure to explain the units in which those rates of heating should be measured and reported. We will not be doing all the tables and graphs, we'll just be doing Table C. So here in Table C, our Y is heating time in minutes, and our temperature is in degrees Fahrenheit. So first we need to find our change in Y. At minute 6, the temperature is 310 degrees. At minute 4, the temperature is 250 degrees. 310 minus 250 gives us 60. And then our change in x, would be 6 minus 4 would be 2. So our average rate of change at this point in time is 30. So our final answer is 30 degrees Fahrenheit per minute. Up next is Unit 2, Lesson 1. Unit 2, Lesson 1 is all about modeling linear movement. Linear movement has two parts, a vertical and a horizontal part. Linear movement is modeled by using the degrees of a circle and a compass. 0 degrees is north on the compass, and each degree goes clockwise around and allows you to determine which direction the vector is heading. In order to find the different parts of a vector, you will need to use trigonometry in order to find the vertical and horizontal components. The three trig functions that we use commonly are shown above. In the above problem, a boat is running due north at 10 knots. The current, however, is running at a 60-degree angle at a speed of 5 knots. We need to figure out at what angle our boat needs to head in order to counteract the left or right movement of the current. Our first step is to isolate the current's vector and to figure out how far it is pushing us from left to right. In order to isolate how far we move from left to right in the current, we need to use the trig function sine. Sine compares the hypotenuse length to the edge of our triangle that is opposite of the angle that we have a known measurement for. As you can see above, I solved algebraically for sine of 60 in order to give us our length of our x, which moves us from left to right. In this case, our theta is 60, and our hypotenuse length is 5. You multiply each side by 5 in order to give us 5 sine of 60 is equivalent to x. In this case, 5 sine of 60 simplifies to 4.33. We now know that the current pushes us from left to right 4.33 kilometers for every hour. During our next step, we will need to figure out the heading that we need to go in order to remain heading due north despite the current. In order to do this, our hypotenuse is 10 knots, the speed of which our boat is traveling. Meanwhile, our adjacent side is 4.33 knots, the speed of which the current is moving us from left to right. In order to figure out theta, or the angle of which we need, we will use the trig function sine. In sine, we will use 4.33, our adjacent angle, and 10 as our hypotenuse. We will use the inverse of sine, which is sine inverse of 4.33 divided by 10 equals theta. Sine inverse of 4.33 divided by 10 is equal to 25.66 degrees. Our interior angle is then 25.66 degrees. Since we need the clockwise rotation in order to get our heading, we will take 360 degrees and subtract our 25.66 degrees to get our final answer and heading of 334.34 degrees. Unit 3, Lesson 1 is all about inverses. Inverses are the opposite of functions. In functions, you put in x to get out y. In inverses, the x is actually the y that you would get if you were to enter an x into a function. It is therefore the opposite of a function. Shown above is a normal function. The first step in finding an inverse is replacing the f of x with a y. The second step of finding the inverse is switching the x and the y. The third step is to solve algebraically for y. Here I subtracted 6 from both sides and then divided by 2 as highlighted. The final step of making an inverse equation is to replace the y with f inverse of x. This is shown with a f to the negative first power of x as highlighted. So here we have a problem. If 12 equals 2x minus 6, what is x? Our first step is to insert the y value into our inverse equation. Our inverse equation is now f inverse of 12 equals 12 minus 6 divided by 2. Replace your f inverse of 12 with x and solve algebraically to get the answer of x equals 3.